beautiful people, and welcome. In today's video, we will be discussing how to write equations from a given graph. And these equations are going to be sine and cosine. We're going to go over how to write a sine and cosine equation for one given graph. Let's go ahead and get started. Before we do, disclaimer time, I am human, so if you catch a mistake, I apologize. Just let me know where the mistake occurs so that way we both can learn from my mistakes. Let's get started. The first thing I'm going to do is I'm going to just give you some steps that should help you to get the information that you need, identify it, write it down, and then make it easier for you. All right, so step number 1 is identify and label your midline. Now, in our class, we do call it our midline. The notes that I'm looking at right now, they are calling it a sinusoidal axle. So I will write that in, but we're going to refer it as our midline. Now, how do we identify or find your midline? Well, what you're going to do is you're going to have your max and your min. So identify those first. And then what you're going to do is you're going to add them and divide by 2. And that's going to give you your actual line. So where on the y-axis is your midline. So, for example, if you get 3, if you take your min, your max, add them together, divide by 2, you get a positive 3. Then your midline is on y equals 3. And then you have your midline there. So I'm going to put y equals midline. Okay, so that's step number 1. Let me zoom this out just a little bit. Okay, step number 2 is determine the amplitude, period, and vertical shift. Once you know your midline, for the amplitude, you're going to use that midline and you're going to count up or count down, because amplitude is the same distance from the midline to the maximum and to the minimum. You only truly need to count up or count down. You have to do both. But you're going to count up to the max from your midline. I'm going to skip period for right now. I'm going to talk about it in just a little bit. A vertical shift is your K value, which is also your midline. So where your midline is, that is your K value. Now about period. Now recall when we are writing our equation, period is not really in our equation. B is in our equation, and we use B in order to determine what the period is. So in order to find period, in order to find B, you have to know the period. And so you're going to, it doesn't matter if you are working with a sine or a cosine wave, you still will have the same period because it starts and ends in the same position. So the distance from the beginning to the end of one period should be the same. So in my opinion, you're going to take your starting point and ending point, and I'll show you an example, and calculate the distance. Okay, you have your starting point, you have your ending point. You're going to calculate the distance between the starting and the ending. That, it will equal the period. So 1 period. Again, what do we need from the period? We need to know what b is. So then you're going to use 2 pi divided by b is equal to your period. And you're going to solve for b. Okay, so that's step number 2. Step number 2 has 3 different chunks. So you have your amplitude, you have your period that you use to solve for b, and then you have your midline. Now, step number 3 is you're going to pick a function. And you're going to identify your horizontal, and then we call it our phase shift. But what it means is just your horizontal shift. Okay, so what do we mean by pick a function? You have, because you can write an equation of a sine wave and a cosine wave from one given graph, you have options. So your first option is a positive sine wave. Second option is a negative sine wave. Or you can write an equation for a positive cosine and a negative cosine. The only difference between our sines and our cosine is a horizontal shift. And then the only difference between our sine and our cosine, our positive and negative sine and cosine is a reflection across the x-axis. Now, this is not part of the steps that I'm just going to show you real quick. I want you to recall in the beginning when we were graphing our parent functions. So we have our sine wave. Here's 1 and here's -1. I'm just going to really quickly graph it. So here's our sine wave. Starts, ends, you can't see that. Let's zoom in. I'm trying to do it like, there it goes. Okay, so our starting and ending is on the axis. So this is for the parent. And then here's the middle. Here's the middle of the middle. And then here's the middle of the middle. That's what I call it, middle of the middle. Okay, that's our sine wave. So if you notice, this right here is kind of a reflection of this one, and then it was shifted. So if you have a positive sine wave, you're going to pick your starting point where you have a positive when it goes up. Now, if you want to write an equation, what you can't see I'm pointing at this. If you want to write an equation using a negative sign, all you have to do is just shift your starting point to where you have it going down, okay? So this right here, it would mean the same equation, except that now we have a different phase shift or a different horizontal shift, because now I'm not starting here, I would be starting here. Now for cosine, notice that cosine starts here at 1, in the middle, goes down to our minimum. And again, notice that things start to shift. If you take this and you move it up, things start to shift. So you can write just in one equation, you can write both sine, cosine, positive, and negative. All right, let's start with an example. I'm going to zoom out. Oh, I keep zooming in, zoom out. And then we're going to start with example number 1. All right, so this is our example number 1. Go ahead and give it a moment to copy this down. What I would highly recommend is pausing this video right now, taking some time to sketch this out so that way you have something to work with, and then you have something to write on. So now that you have that done, again, if you haven't, pause it, copy it. Otherwise, we're going to move on. Okay, now that we have this done, we're going to follow our steps. Now I have my steps next to me, so I'm going to follow that. Step number 1 is identify and label your midline. Okay, so our maximum value refers to on the y-axis. So our maximum value is 4. Our minimum value, what is the smallest it can be? It can be -2. So how do I find my midline? I take my maximum plus my midline, or my maximum plus my minimum, and I'm going to divide by 2. So 4 plus -2 is 2 divided by 2. So my midline is y equals 1. That's my midline. So at 1, that is where our midline would be. Now, I typically don't do that. I promise you guys, I will tell you everything, all the little tricks if I can. I typically don't do that. I know that my midline is halfway between the maximum and my minimum. So then what I do is I just count. So I say 1, 2, 3, 4, 5, 6. 6 divided by 2 is 3. So 1, 2, 3. At 3 jumps, you have your midline. Now, again, if you do it this way, this actually tells you where your midline is. If you do it my other way, just by counting, then you have to count to find your midline. Okay, so we have our midline. So that means the distance above and below is our amplitude. So again, I only need to count either above or below. I don't need to count twice because it's the same distance. So what's my distance? 1, 2, 3. So my amplitude is 3. Okay. Now what do we do? Now I'm looking at my step. So amplitude was step number 2. Vertical shift. So we know this is going to be our K. So I'm just going to start listing these out. Here's my midline, which means my K is also 1. My amplitude is now 3. Now for the period. I know for the period that we start and end at the midline for my sine wave. So if I want to do a sine wave, I'm going to start and end at my midline. So where is our midline? My midline is, let's do here. And then we start and end at our midline. Okay, so what is my period? So I need to know what the distance is from negative pi halves all the way to 3 pi halves. So I need to know what this distance is from my starting to my ending. Now, I want to back up just a little bit. The reason I didn't start on my x-axis is because the characteristic of a sine wave, it starts and ends on your midline. So, okay, so because your midline is at 1, that means you have a vertical shift of positive 1. So you have to identify your starting and ending on your midline. Okay, so now we have negative pi halves and 3 pi halves. That would mean my distance is 4 pi halves. Again, I'm taking the absolute value of this and adding. So if I go 3 pi halves here and I go another pi halves, that is, so period. That means 4 pi halves, which means my period is at 2 pi. So again, what do we do with that period? We have to find what b is. So I'm going to take 2 pi divided by b is equal to 2 pi. This one's a little bit easier because it's not making you solve. You can just figure this out without multiplying. I'm still going to do it just to show you if it wasn't this simple. So I'm going to say times b times b. So 2 pi is equal to 2 pi times b. Again, I'm only doing this to show you what to do if it is a little bit more complicated. So b is equal to 1. I'll write that down. So I have my k, my a, my b. We decided that we're going to work with a positive sign because that's where I determined my starting point. My starting point and ending point gives me a positive sign function. So I'm going to write positive sign. And then the last thing is your phase shift or your horizontal shift. So here's my starting point. So we need to know where did it go. So my starting point went to the left at negative pi halves. So then we have h is equal to negative pi halves. So remember, when you are writing the equation for your horizontal, your phase shift, it's always going to be the opposite. So we have everything that we need for writing our equation for a sine wave. So let's write, I'm going to have this here. So y equals, start out with a, which is 3 times your positive sign, then your b, which is 1, parentheses, you can use x or theta, I'm going to use theta. Then you're going to go to the left pi halves, which means we're doing a plus pi halves. Remember, this is always opposite. And then your k value is 1. So let's simplify this. I have 3 sine pi plus excuse me, theta, not pi, 3 sine theta plus pi halves, plus 1. And that is your equation for your sine wave. Now we're going to do exactly the same thing, but for our cosine, okay? So I'm going to bring it back here. I'm going to erase my starting, because now we're doing our cosine. Midline doesn't change, amplitude doesn't change. Whoop. Now we're doing our cosine. Remember, cosine looks like something like this if it is positive. So I'm trying to find something that looks like this. So here is my starting. Here is my ending. So now here's my end. Here's my start for my cosine. Now, again, period doesn't change, but I'm going to show you why that doesn't change. Because now here's our starting, so we want to know the distance between our start and our end. So starting is at 0, ending is at 2 pi. So our period of 2 pi doesn't change. It is still 2 pi, so our b value is the same. So for writing cosine, I'm just going to list the information. Amplitude doesn't change. It is still 3. K value, our vertical shift, doesn't change. It's still 1. The b value, still 1, doesn't change. What does change is that now that we are using a cosine, and it's going to be a positive cosine. Cosine is positive if it dips down. Just remember that. And then we need to figure out if there's any horizontal shift. So is it starting anywhere other than at 0? And it is not. So then our phase shift, or our horizontal shift, is 0. Now that we have all of our information, let's write an equation. I have y equals a, which is 3. Now we have cosine. We have b is 1, theta. We have 0 phase shift, so I'm just going to write 0 here. You don't have to. We'll simplify it. And our vertical is still 1. So let's simplify this. I have y equals 3 cosine of theta plus 1 as my equation for this wave that's given here. All right, you guys, let's do one more example. Again, follow your steps, and hopefully this should be okay. Let's move on to example number 2. All right, for example number 2, just like example number 1, I recommend you pausing this video, making a sketch on your notes, so that way you have something to work with while we go over this together. Now that you have copied it, I hope so, fingers crossed, let's go ahead and go through our steps. I still have my steps in front of me. Step number 1 is identify and label your midline. Again, if you want to use the formula max plus min divided by 2, you can. I don't do that. I just count. I have 1, 2, 3, 4 jumps between my maximum and my minimum. That means 1, 2 jumps would be my midline. Again, I'm just counting distance. If you do it the other way, you will actually know your midline. So again, 1, 2, 3, 4 jumps divided by 2 means I have 2 jumps. 1, 2. So your midline, and I'm going to start kind of identifying my information. Midline is at y equals -1. So that means my k value is -1. Amplitude comes next. From your midline, count up to your maximum and see what is your distance. My maximum is at -1, so my distance is 1, 2 jumps. So my amplitude is 2 jumps. Okay, next thing is we need our period. So when you determine your period, you also determine if you're using a positive or a negative sine wave, positive or negative cosine wave, okay? So what I'm going to do here is I'm going to start out with a cosine wave. It just seems easier a little bit for me, but we'll do both. Okay, so cosine wave for me looks a little bit easier because I have a maximum here and I have a maximum here. So I start and end on my maximum for cosine, and my middle is my minimum. So I can find my period here. And choose the one that's easier to do first. So if you see a cosine, do that first because your period is going to be the same for your cosine and sine wave on the same graph. So if you find the easier one, you don't have to do it for the other one. Okay, so what is our distance? If I'm here at negative 3 pi, and I'm here at negative 3 pi, so what is our distance? Well, the distance between here and here is pi thirds. The distance between here and here is pi thirds. Remember, distance cannot be negative, and I'm just it's very difficult for you guys to see this, but I'm just sketching it. So the distance is pi thirds, and the distance is pi thirds. So what is the total distance? So period is 2 pi thirds. So again, what do we need out of our period? We need to determine what our b value is. So how do we do that? We set 2 pi over b equal to whatever our period is. Now I'm going to show you a trick. Okay, I'm going to show you a trick. Notice how this is a fraction and this is a fraction. We need to solve b. Just flip it. So I have b over 2 pi equal to 3 over 2 pi. Now again, if you already see the answer, I'm happy for you, but I will continue to solve just so you know. So I'm going to multiply both sides by 2 pi. Again, only doing this for those of you who don't already see the answer. So then these cancel out, b is equal to 3. We have our k, we have our a, we have our b. Now we are working with our cosine, positive cosine because it's going down, and we need to know what our phase shift or our h is. So again, sine and cosine, the parent functions start at 0. So they start at on the y-axis. So if it is not on the y-axis, we have to figure out by how much did it shift. So in this case, we start out, this was our start. We started at negative pi thirds. So when we write our equation, it has to be the opposite. So let's write our equation. Our equation is y equals, what's our a? Our a is 2 times, we said it was cosine, positive cosine. Then we said our b is 3. I'm going to use theta. Our h is negative pi thirds, so we have to write the opposite, which is positive pi thirds. And our vertical shift, our k, is negative 1. Let's simplify this. 2 cosine, oh, that is simplified. I'm just going to rewrite it to make it prettier without the dot. And that is your equation for your cosine wave. Now, we still have to write the same equation, I guess not the same, but we still have to write the equation for a sine wave. So let's go ahead and erase our starting because now our starting is going to be different. Remember, period's going to be the same, everything's going to be the same except your shift, your horizontal shift or your phase shift. And what else is going to be different is obviously your sine, the fact that we are writing sine now instead of cosine. Characteristic of a sine wave is that it starts right here on the midline, it ends on the midline, and it has a middle on the middle. So whenever you are trying to figure out where something starts and ends, go back to the characteristics of the parent function. For a sine wave, it has to start and end on the midline with the middle on the midline as well. So you have 3 points on the midline. Once you identify those 3 points, you have one going up, you have a curve going down, you now have one period of a sine wave. So again, we're going to start here, and we're going to end here. Now, don't worry about period because we already have that, but I'm going to still do it just because some of you maybe didn't see the cosine on here, so you might want to do a sine. So this one here, what is this? Well, each distance is pi 6. So this is 1 pi 6. This is 2 pi 6. So this is 3 pi 6. Obviously, we can simplify that to pi halves, but this is technically 3 pi 6. This part right here is pi 6. So what is the distance? I have the distance from my y, or 0, is from 0 to 3 pi 6, and I have a distance of pi 6. So my period still ends up being 2 pi thirds when simplified. So nothing else changes except our horizontal. So now our horizontal is what? Where does it start? Well, it starts at pi halves. Make sure that you're simplifying in your final answer. So it starts at pi halves. This is where my starting is. So how will our equation look like? Well, it's going to look like y equals, what's our amplitude? Our amplitude is 2. We are now choosing to do a positive sine wave because it goes up. So 2 times sine, what's our b value? Our b value is 3 times theta. H is negative pi halves, so do the opposite, which is positive pi halves. And our k value, our vertical shift, is negative 1. So our equation for this graph using sine is y equals 2 times sine of 3 of theta plus pi halves minus 1. So both for one equation. And that's it. That's it. All right, guys. Wrapping up the video. It was a little bit of a shorter one. I think you would appreciate that. I appreciate it myself. As always, if you caught a mistake, let me know where the mistake occurs. I do apologize in advance if there are any mistakes in this video. As always, reach out to me if you have any questions, if you have any concerns on what we're doing here. And I hope you all the best, and I'll see you in my next video.